Okay, so the one that we just looked back here, there is a pattern. We're trying to find the 43rd. We did get 173. Now that we're looking at this one, there is a pattern. I'll pause the video. Try to tell me, I'll give you like 2 minutes. Tell me, how many do you think, how many blocks are on the 43rd? Alright, actually, my bad, no. The answer for this is 4,398,046,511,104. Okay? This is the pattern. Because n is 1, n is 2. And what I want you to do is, first of all, you have to understand the notation so that you can understand the patterns. Okay? So here we go. Let's start with the notation. Some of you probably have waited in line for a movie. You've waited in line for a new iPhone. You've waited in line for a new release of something. You might have, I don't know, for Black Friday, stayed out overnight for a TV or something. What I want you to know that n is your location in line. That's important. Now I'm telling you, it sounds like it's so duh, but if you don't understand the fundamental with certain things, then it gets real pretty fast. So if I said n is 1, I'm talking about the first item in line. It doesn't say what its value is, it just says what's the location. Okay? So if I said, for instance, n is 1, and if I said a sub 1, that means what is the amount of the first person in line? I'd say 1 box. Looking at this, this is n is 2. So what is the amount of the second one in line? You'd say 2. You see what I'm doing right now? So if this is location number 3, otherwise the third one in line, help me out. What is a sub 3? 4. What is a sub 5? 16. So a sub 4 is in between at 8. And if you see the pattern already, what are we doing each jump? We're doubling. That's where this doubling 2 comes from, right here. And if I want to know the 43rd figure, that means I'm going to double it 42 times, because the first figure started at 1. Do you understand? So I'm going to take 2 to the power of 42, which I know that weird caret is there, but it would give you this, and that's how you get that 4,398,000,000, so on and so forth. Okay? Now, let's do this one. They get a little bit more intense, and your goal is to develop a pattern. Okay, some of you are really good at this, and you were good at it like in first grade, whenever you would see those patterns that they gave you in math class or whatnot. Some of you it struggles just a little bit more because you're trying to come up with equations that represent the pattern. What commonalities do you see right here? Two extras. Nice. That's exactly right. These 2 extras are important. And I like your choice of words. What other patterns do you see? Well, numbers, not colors, but adds a row and a column.
They go up by 5.
They go up by 5?
Look in total.
Okay, so here you have.
Never mind.
Okay, no worries. I mean, because you're going to do trial and error. You're going to try to come up with patterns, and your goal is to see which one works all the time. Okay? You have 5 here. You have how many here? 10, 17. So they're not going up by 5, but at least you're trial and erroring. Okay? That what you just tried is an arithmetic sequence. Okay? This one's a little bit more difficult to see, and it's in fact this right here. Okay? What Jeremy was talking about, these additional 2's, is right here. N represents what that you see right here? Placement. The person in line. This one is n is equal to 1. This is the second term in line. This is the third term in line. And now we've created this equation where if you're the first person in line, it'll be 1 times 3 plus 2. Did I get my boxes here with this equation right here? Yes or no? So 3 times 1 plus 2, you get 5. right here it's going to be 2. Why is it 2? Because it's the second one in line. You got to make sure that you're understanding what to analyze. Don't think it's 2 because there's 2 rows. Okay? So the second one in line, and then that means n is 2, should be 2 times 4 plus 2, 8, 9, 10. And you got 10. And it just keeps going on and on. Your goal, guys, during this unit is basically to come up with these patterns. You need to come up with these equations. Okay? All right. Today what we're going to do, we have the arithmetic and geometric sequences. We'll talk about sequences in general, and then we'll talk about series as far as what do they relate to and how do they relate to sequences in that respect. Okay? So let's go ahead and start off. And again, you guys are more than welcome to follow me with the post that's on Google Classroom, and you can see how we're going to do this. First and foremost, I want you to grab that blue sheet and that yellow sheet, and you're going to fold them like this. So if you can look up here, you're going to fold this one down to where when you fold it, it will give you the attributes of a geometric sequence. Okay, and this is going to be at the top, or sorry, the bottom of that first page. The yellow one is going to be on top, just like Lauren folded it. That's how you're going to fold it here, to where, and you're going to have to cut the sides because it's a little bit wide. But then you're going to glue all this to your paper, so when you open it up, boom, there it is for your notes. Okay? So let's go ahead and start with the arithmetic sequences. All right, this word, you just heard me pronounce it. How do you think you would pronounce that? Arithmetic. Arithmetic. And basic arithmetic, when you learn basic arithmetic in elementary, what do? You're adding and subtracting. Okay? So put adding and subtracting. Okay? And the thing is, an arithmetic sequence is actually showing adding. And a lot of times the way we find it is that we're going to work backwards and subtract. Okay? Geometric. What do you think you're doing with geometric? Multiplying. Multiplying, and you're going to solve it by dividing. So you're going to do the opposite in order to solve the pattern. So to solve something that's being multiplied, we're going to divide backwards. To solve something that's being added, we're going to subtract backwards. All right. So now we're going to go to terminology and words and vocab. First one is a sequence. And the most important word that I can say is a list. That's it. It's just a list that shows a pattern. And this right here is a sequence. It has brackets, otherwise braces, and it has commas. Nothing's added, nothing's subtracted, you're just showing a list. Can someone show me or tell me what is the pattern amongst this list that you noticed? It's double. So you're multiplying by 2 each jump. There's a jump. There's a jump by multiplying by 2. There's a jump by multiplying by 2. That's not 0.2. I'm putting a dot for multiplication, guys. Okay? And because of the fact that this is multiplication, this right here would be a geometric. Okay, so this is a geometric sequence. All right, term. It's a number in the sequence. Okay? So you guys have now 5 minutes that you can put pencils away and you can use your notes, okay? And then after the 5 minutes, you can go ahead and finish it off. Now, let's look at a term. Okay, so the term that you have now, it says it's a number in the sequence. So the term, the letters with subscripts. So the third term is going to be a sub 3. The fifth term is going to be a sub 5. Those are those placement in line that I was telling you about earlier. That's your position. So the position. N is 1 is your first term. N is 3 is your third term. That's the place in line, okay? It's called the ordinal location. That's just a fancy schmancy word for saying the place in line. All right, here we go. Explicit, I think, is easy. This is what you were doing at the beginning of today's notes. Explicit is easy because this is what you would normally do by intuition. This right here, the recursive, is like this rough draft, if you will. The rough draft, if you like English just as much as I do, and that was facetious, the recursive is like the rough draft. You're trying to find out what is the pattern. And how am I gonna write it out as far as equations go? And when I have my final product or whatever, my final copy, that's the explicit formula. And that's what you're gonna put into your calculator. So this goes in the calculator. So it's a formula for finding any term depending upon the position. Where this, it's a process. Okay? These are the formulas, and this is more like the process or the words. You're talking yourself through the problem and trying to figure out what is the future going to be based off of the previous terms. Guys, this math right here, I'm not even kidding. This math is really powerful, especially when you use it with calculus and Calc BC and Calculus 2 in college. It can predict futures and models of futures a lot accurate, more than what we've already done with the stuff that we worked on this year. Okay? So in this case, someone read that for me. What does that read as? Okay, so let's say a sub 1 is 2. Okay? And what does that mean? It means the first term has a value of 2. Okay? So now, look at this. Now, I want to introduce notation, and I'm not even kidding. It's a lot easier than it looks. It's just that you need to be explained it in a way that you're like, oh, duh. Okay? A sub n plus 1, a sub n minus 1. It looks more intimidating than what it actually is. And the way that I want to show you is, let's say n for now, right now, the present, okay? The present right here. One step into the future is going to be basically the next or the following term. Does that make sense? And then the one in the past over here is going to be one term ago. Guys, this is huge. So the past term. I know it looks straightforward, but when people start working with the equations and stuff like that, they get lost big time, okay? So I want to make sure that you understand fundamentally what this is representing. Let's go to the equations. Look at this. This looks a little bit intimidating, but it's a lot easier than you think. This says right here, let me highlight it as I go. The now term's value will come from the previous term times 2. And that's how you need to know how to read it, okay? So over here, a sub 6 will come from the previous term, which is a sub 5, times 2. If they're saying that a sub 5 is 32, and I multiply that by 32 to get 64, that means the sixth person in line, their value is 64. How would I figure out the seventh person in line? Well, the previous term times 2. Can anyone tell me what a sub 6 is? 64. So what's the answer for a sub 7? 128. What would be the answer for a sub 8? 256. Because you're going to take the previous term and multiply it by 2. 256. Okay? Alright guys, go ahead and put your notes away, you can finish up. Alright, in this case, here we go. In this case, a sub n is equal to 2 to the power of n. Here was multiplication growth. Here is exponential growth. You with me? So here we go. A sub n, if I said what's a sub 10, that means it's 2 to the power of 10. Can someone do that with a calculator real quick? It's a pretty big number. 2 to the power of 10 is what we're going to put in here. What'd y'all get? 1024? So 1024. 2 to the power of 14 is even bigger, 16,384. Any questions right now from what we're doing? Yeah.
1024 was multiplied by 2.
I did was I put 14 where n goes. And 2 to the 14 power is 16,384. Okay? But I know what you're feeling and struggling with right now. Here's what I'll say. N fundamentally is just the location. Okay? You'll see what I'm talking about here in just a bit when we start looking at these examples. For instance, here we go, guys. This right here is going to be an arithmetic sequence. And it's arithmetic because of this. Watch the pattern. What is happening to go from 5 to 9? I'm adding what? I added 4. What is happening to go from 9 to 13? You add 4. What is happening to go to 3 to 17? Add 4. And I know that means redundant, but I did it 3 times for a specific reason. A pattern is established when you've proved it 3 times. So the pattern here is going to be a positive 4 because you're jumping up by 4. Now here is the confusing part. Don't let it confuse you. To realize that this was adding, I want you to show the work of subtracting. So you would show this. 17 minus 13, 4. 13 minus 9, always 1 from the past, 4. 9 minus 5, we get 4. And sure enough, if we can show a pattern with 3 of the same number, then we have the right pattern. Okay? Let me show you with number 2. And you could take any of these 4s. Negative 2 minus 3. 3 minus 8. 8 minus 13. Okay, like Judd did the other one at the very beginning with jumping up by 5. Sometimes they will work on the first try, and sometimes they won't, and you have to try something else, okay? What's negative 2 minus 3? Negative 5. How about the next one? Negative 5 and negative 5. So negative 5 is your common difference. It's dropping by 5 each jump. Okay? Over here, subtracting these, then subtracting those, and subtracting those, you're going to get the common difference of, what do we get for that first one? Okay, so here we go. To find if it's arithmetic, subtract. To find out if it's geometric, divide. Okay? So let's say 949, be handy with the calculator please, minus 682. Then do 682 minus 415. Then do 415, oops, minus 148. What do those numbers give you? 357. Are they all?
267.
Oh, 267. Are they all 267? So there's your pattern. You're going up by 267 each time. Okay? But either way, like over here we subtracted, but we were showing that it was a pattern of a negative 5. And then guys, over here, what would this pattern be? Those of you, because I see some of you working ahead, what would you get for a common difference on number 4? 30 what? 43. 40. What is it?
Negative 43.
Say it one more time, guys.
Negative 43.
Okay, negative 43. All right. Let's now go to where it gets real. So this was the easy part. Okay, and it is pretty straightforward. But when people start seeing this notation, especially right here, they freak out. Okay, and it's not as difficult as it looks. To me, I think this is easier. And this one's a little bit difficult, just a little bit, as far as what students struggle with. Okay? Let's go ahead and start. A sub 1 is 15. What did I just tell you? I know, but what does that mean in layman's terms? The first term is 15. So we're going to list it out as 15. And now we want to list the first 5 terms. And we're going to look at the recursive formula that they're giving us that is right here. Okay, that's the recursive formula. Let me go through it with highlights. The term that I'm looking at right now will equal the last term plus 24. I'll say that again. The now term equals, so the now term, otherwise the end term, equals 1 step ago plus 24. You with me? So, what would this next term be? What would the second one be? It would be what? 39. And then? 63. Keep going. 87. And then? 111. First 5 terms. There are the first 5 terms that have been listed. Now, let's think about this, because this is where people struggle just a little bit. Can someone tell me what 87, the number of the term that 87 is? A sub 4. So A sub 4 is 87. Okay? And if you solve this, what would n be? 4. Means the 4th person in line. You with me? So if I'm looking at this equation, and I wanted to solve for the, let's say, the second term, I would say the second term is equal to a sub 2 minus 1 plus 24. Notice what I just did. I'm looking for n is 2, so n would be 2 right there and right there. Can someone tell me, what does this make a sub 2 minus 1? What is this? What does it make this when I do the 2 minus 1? A sub 1. So it's saying the previous term, which is a sub 1, adding with 24 would give me a sub 2. A sub 1 is 15. When I add 24, sure enough, I get 39. Okay? Understanding n. Okay. So now that I'm jumping up, check this out. You've done it since Algebra 1. It just has to be explained to you in a way that you see it. You've seen this. Y equals mx plus b. To me, I wish they would have taught you this way, because you use it so much more in math. Y equals b plus mx. Why would I want them to teach you this way? Because b is where you start. M is how you change per jump. Okay? So the way this is color coordinated, there's my jump. How much are you changing each jump? Right here. You with me? Where do you start? Well, you start here. Is it starting to make sense? As far as the a sub 1 and so on and so forth. Okay. So if I'm looking at the explicit equation, guys, it's going to be a sub n. The now number will be starting at 15 plus, what is the jump that y'all see here? Plus 24. This is the jump right here. This jump is going to say I'm going to jump by 24 each step of the way. So my jump, I put it in orange, is going to be this. Where I started, I put it in green up above, is going to be this. And then each jump that I go is going to be that right there. Questions? Okay. So, I'm going to call on you, so be ready. I'm going to call on you by name. I'm going to ask you different pieces of the explicit, the recursive, and the formula. Okay? First of all, let's start with number 6. We'll go with Eric. Number 6. A sub 1 is 108. What does that mean? It's the beginning, so 108. Eric, can you tell me what the other 4 numbers are going to be? And try not to look at your notes. I want you to understand the jumps. Subtract 12, right? So let's keep going. Subtract 12, what do I get? 96, and then 84, 72, and 60. Guys, you see the jump. The change per each one is by 12, by negative 12, because it's going down. Okay, again, I know the notes are in front of you. And if you can do it without looking at it, please, I do prefer that. Megan, let's go with 6. What's the explicit formula for this pattern that you see? Remember, it's going to have this form right here. Y equals b plus mx. A sub n equals 8 or 108
minus
minus 12. Keep going. And you got to say per jump. And what's the per jump notation? Someone help her out. In minus 1. Okay? So you started, again, you started here. That's that B. Plus the M. So it was changing by 12 each jump. And this just tells you which term you're on. Okay? It'll always be in minus 1. Can someone tell me why? That's a big key. Understand?
It's the previous one.
It's the previous one, but more important, check this out. It's where you start, and on a graph, okay, let's say that we had a graph that looked like this. Would this be safe to say that this graph right here as a line is y is equal to 2 plus, let's say, x? Otherwise, x plus 2. Because look, this is where I cross the y-intercept. That's that b value. And I'm going up by 1 each step of the way. You go with me? Can someone tell me what is the value of x if I start, at 2? What's the value of x? No, if I'm starting at y is equal to 2, right here at this point, it's 0. So here, what would n minus 1 become to make this 12 0 out? Well, n would have to be 1. This is very important right now. If n is 1, then 1 minus 1 is 0. Negative 12 times 0 goes away, and it says a sub 1 is 108. Okay, that's huge right there. All right, let's do the next one. Looking at this equation down here at the bottom right, can someone tell me how much am I jumping by every jump? 8. Where do I start? 6. Am I multiplying or adding? Adding. So it'll be 6, 14, 22, 30, 38, and 46. Is that correct? Okay. Over here, recursive formula. What is a sub 1? 6. Here we go. Now watch as I write this. The now term equals a term ago plus what? 8. Guys, seriously, the recursive, the explicit, which one do you feel like you like better? The explicit. And the recursive is just weird, right? It's like, anyway. Let's do for the last one. I'm going to erase just some stuff so I can clear it up. The last one for number 8, where is it that I'm starting with the sequence that they listed? 20. So I'm going to say a sub 1 equals 20. Now, here we go. The now term. It could be the 10th, the 11th, the 12th, whatever. The now term is the last term, then what? Minus 9. So over here, it's going to be the now term starts at 20. It jumps down by 9 each jump, and each jump is going to be always n minus 1. Go with me? So where you start, let me highlight it. Recursive, there it is. Explicit, there's where you start. How much you jump by is written here and here, and then each jump is going to be shown by that n minus 1. Okay. All right, so I'm going to speed it up a little bit because it looks like a lot of you are getting it pretty easily. This right here is the geometric. And geometric means we're going to multiply. So let's look at number 9. The way that I would want you to do this is I would look at number 9 and I would try subtracting first, and if subtracting didn't work, most likely it's going to be multiplication. So I would want you to do like 432 minus 72, 72 minus 12, 12 minus 6, and already you can, 12 minus 2. And already you could see yeah, this is not going to be arithmetic. Because this one right here is 60. This one is 10. Yeah, they're not the same. And you might do that trial and error just like Judd was doing at the beginning of class as far as the 5 jumps, okay? Here, if the subtraction doesn't work, we're going to immediately go to what? Division. So we'll say 432 divided by 72. 72 divided by 12. 12 divided by 6. Or sorry, 2. And sure enough, all of these equal 6. So because it was through division, we know that these are going to be geometric common ratios. Look at that. The common ratio is a fraction. That's what you were getting with all these ratios. The common one is 6. So R is 6. 10. What does it look like for 10? Well, if it's not obvious, you're going to have to go to these numbers and say 68.6 divided by 49. 49 divided by 35. And so on and so forth. And then 35 divided by 25. What does that common ratio look like? 7/5? Is that right? 7/5? So 7/5, 7/5, 7/5. Common ratio 7/5. What's important about 7/5 right now that you think I'm wanting to ask you? The fact that it's what? Greater than 1. Because if it was 1, there's no growth. But if it's bigger than 1, it almost feels like a vertical stretch. So the numbers will get what? Bigger. If it's less than 1, the numbers will approach 0. You with me? Look at 12. Do y'all see the pattern? What are they doing each jump to do 12? Dividing by what? Not by negative. Dividing by 3. And if you don't see it, do 1 divided by 3. 3 divided by 9. Remember, the jump divided by 1 jump in the past. So 1 divided by 3. 3 divided by 9. 9 divided by 27. All of these reduce to 1/3. So look at that. Something that's between 0 and 1 will be a compression, like a vertical compression interpretation. And it is decreasing. So R is 1/3 here. Now this one's different. This one's alternating, okay? What is this one going to be as far as this negative is concerned? What is it? What would be negative? You could put 16 over negative 20. You could put negative 20 over 25. The 16, they both have 4. And they both have 4, or 5 that is. And you get a negative 4/5. The negative makes it alternate. Positive, negative, positive, negative, positive, negative. The 4/5 makes it go less and less and less and less. Okay? Alright, I'm going to follow you now. I'm going to close mine so that you can see too. What are the first 5 terms with number 13? Let me call on some people, okay? So we'll go with Diego. What are the first 5 terms that are on 13? Where do we start with? 16, yep. Then 8, good. 4, 2, yeah. 1, 2, 3, 4, 5, one more. And then 0.5 or 1/2. We'll do 1/2, okay? Alright. Let's do the next one. Let's go with Saeed. Number 14. What are the first 5 terms? Yep.
21.
63. 1 what?
189.
Yep.
And 567.
Cool. Okay. Let's now do the explicit formulas. Lauren, what's the explicit formula for 13?
The first term, so A and then N.
So A sub n, right? A sub n equals?
16 times 1/2.
Okay, so you've already said it different. What did she say that was different from what we were doing before? She's multiplying, not adding or subtracting. So it'll be 16 times 1/2. Raised to the what?
N minus 1.
N minus 1. Guys, This is very important. A lot of people make this mistake, especially on that quiz. Can I look at 16 and 1/2? And you tell me, and then tell me why. Can I make this an 8 to the power of n minus 1? Yes or no? Huh? No, I can't. Why not? Order of operations. PEMDAS says I have to do exponents first and then multiply with that 16. So don't combine the 16 and the 1/2 together and make it 8, please. Do not do that. That's huge no-no. All right. Evelyn, let's go with number 14. A sub n equals?
7 times 3 to the power of
Perfect. Okay. Now, let's list out, Megan, let's list out the first 5, okay? On number 15. What do you have?
100.
Okay, 100. Keep going. And you can use your calculator if you want. Someone help her out. What is she going to do to this 100 to get her second number? Multiply by 60% or 0.6. Okay? So what do you get when you multiply by 0.6? 60. Okay, now take that number and multiply that by 0.6. 36. Keep going. 21.6. One more. Remember, we're multiplying it by 60%. 12.96. Okay. Are we good? Are we good, guys? Okay, Jeremy, over here. What am I going to list as a sub 1 for my recursive? 100, good. And keep going, Jeremy. What am I going to list for a sub n?
You're going to put parentheses a sub n minus 1 times 0.6.
Perfect. And notice how he said times rather than adding because these are geometric. Geometric on multiplying, we're arithmetic, we're just the adding and subtracting. Kaylee, let's do the last one, 16. Let's do the recursive formula. What would a sub n or a sub 1 be? 81. And then what would a sub n be?
A sub n minus 1
Yep. Times. And while she's doing that with the calculator, we can set it up. We'll do 3 of them. Remember, a number divided by the past number, number divided by the past number. We got to make sure that these are all the same. 2/3. Yep. Times 2/3. So over here it would be a sub n starts at 81, and you're multiplying it by a common ratio of 2/3. It's less than 1, means it will shrink, and it's to the power of n minus 1. Okay? Now, the first term, which is a sub 1, this is huge, guys. I'm saying n is 1 for the first term. That means right here I would put 1. And what's 1? Obviously, what's 1 minus 1? 0. What's 2/3 to the power of 0? 1. Anything to the power of 0 except for infinity and 0, these are the only two that will not equal 1. Everything else will equal 1. And what's 1 times 81? My first term. Okay? All right. Now we come to the word problem. So we have these 4 pages of notes pretty much left, or 4 little smidgets of notes, and then we are done. Okay? Let's look at page 113. This is where people struggle a little bit. All right. First of all, it says, write the first 5 terms of the sequence. Okay? Well, I know that it's starting at 94. And I know that it's going to subtract, because D is common difference, so it's arithmetic. So these are arithmetic. That means adding and subtracting. This is arithmetic, this is arithmetic, and these two are geometric. Means that they're going to be multiplying and or dividing. Okay. So the first one is 94. Can someone tell me what the second term is going to be? 86. It's because we're subtracting by 8. And then
78.
78, 70, one more. 62. Perfect. With braces, with commas, no addition, there's my sequence. It's just a list. Write the explicit formula for a sub n and use it to find the 20th. Here we go, guys. This is what we're trying to do. We're trying to come up with the equation so that we can put 20 in for that letter n and see what value do we get. Guys, what do I write after a sub n? 94. Oh, minus 8 and minus 1. Because look, check this out. We just did y equals b plus mx. That's what we just did. Okay? And now that I want to know the 20th term, all I have to do is just put that there. And say that my a sub 20, otherwise my 20th term, 20 minus 1, 19, right? Times a negative 8. You know what I mean? So you can put this into your calculator, and you'd say 94 minus 8 times 19. What do y'all get in your calculator whenever you do that? A negative what? Negative 58? Do I have a second on that? Okay, so my 20th term's value is negative 58. Alright? Let's do 18. Arithmetic sequence. This one's different. Has the first term at 19 and the sixth one at 50. Okay? What is D, the common difference? Watch how I set this up, because this is different, okay? And yes, you know as well as I do, whenever you see the stuff in class, then you go home and you're like, ooh, this looks different or difficult. That's one of these problems right here, okay? So I really want you to check out, see what's happening right now. I would write it as a sub n is equal to 19 where it starts. We don't know D, but we know that it's going to be n minus 1. This is huge right now, okay? What would you do from here, guys? Because right now you have two unknowns. And one of them, you actually know. You just got to find it. Which one are you given? D or N? N. We know N. What's N? 6. The sixth term, this would be a sub 6 is 19 plus D, 6 minus 1. Y'all with me? So then, what's a sub 6, guys? 50. Plug it in. So if this is 50, my only unknown now is D. And how? Because I know that n represents the term in line. So I have 50 is equal to 19 plus 5D. Subtract the 19. D is what? 31 over 5. Yep. 6.2 if you're going to put it as a decimal. And now, the reason why we found D is so that we can put it right here. It was almost like a general solution, and we made it a particular solution because we found our constant of jump, which is 35 or 31 over 5. So now it's a little bit more exact, more descriptive. And now if I wanted to find the 20th term, all I'm going to do is put that 20 right here and right here. And whatever this is, that's my answer. Okay? So, please put that in your calculator. A sub 20, or sorry, put this. You should put 19 plus 31 over 5 times 20 minus 1. Which you can just write 19 if you want. What do you get for that? Can you say it a little louder? 136.8. That's the value of the 20th term in line. Easy enough, right? Okay, so now we're on a scale from 1 to 10, fundamentals being like 1 through 3. These are a little bit more advanced. I'd say these are about 5, maybe 6, okay? There's more that we're going to get to here in just a bit. The geometric sequence has a sub 1 is 2 and r is 5. Here we go. Where do you start? 2. And you're going to multiply each time by how much? 5. So here we go. 2 and then 10 and then 50, 250, and 1250. Okay? Write the explicit formula for a sub n and use it to find the 10th term. So this one's a little bit different, okay? A little bit different. CJ, how do I start this off for B? Remember, we're doing the explicit formula, and we're starting at 2.
So you just want like the basic.
Yeah.
Alright. A sub n equals 2 times 5.
Okay, a sub n is equal to 2 times 5.
N minus 1.
Yep, to the power of n minus 1. Remember, this goes in the power if it's geometric. If it's not, it goes downstairs. Alright, and then the 10th term, you're just going to put 10 in for n right here, and you'll get a sub 10 is equal to, what does it have? What's 5 to the 9th power times 2? It's probably a huge number, right?
3,006,000.
Okay, yeah, I'll just let you write that down. Okay, yeah, whatever that is, just go ahead and write that down. 5 to the power of 9 times 2, and then you're good to go. I'll do the last one. Here we go. So the geometric sequence, when I'm starting at 4, and the third term is 12. So it's like saying this is 4, and then 2, and then 3, and then it can go on forever and ever. And we want to know the 7th one in line. Okay? So I know the first one in line. I know the third one in line. I don't know the second one. 4, 5, 6, and I want to know the 7th. So I'm trying to find what is that value right there ultimately. You with me? This is a lot like 18 was over here. We have to set up our initial a sub n is equal to my a sub 1 times r to the n minus 1. That's our explicit default formula for geometric sequences. And then, can someone tell me what I'm going to put in for that letter right there? Or a sub 1? I'm going to put 4. Because it's the first term. Right? So, what am I going to put for r? Or do I know that yet? I don't know it yet. So let's write what we know. Is equal to 4 times r to the n minus 1. Do I know n? Yeah, what's n? Not 1, and this is where confusion plays in. Not 1, it's actually 3. Watch how I'm going to do this. I'm going to use n is 3. So a sub 3 would equal to 4 times r to the 3 minus 1. Can someone tell me what a sub 3 is? 12. Do you see how I'm doing this, guys? All because of the placement in line. And now I have one variable that I can solve for. Because 3 minus 1 is 2, which is r squared. So I now have 12 is equal to 4 times r squared. Divide both sides by 4. Square root both sides to get r. And there it is. So what did I do? I used those two numbers to help me find the fact that I know where I'm starting, which is 4, and I know that each jump I'm going to multiply by the square root of 3. And this, all I have to do now is put in 20 for my n term, and I will be able to get what this number is. So square root of 3 to the power of 19 times 4. Oh, my bad, not 20. You should correct me, my bad. It would have been 7, right? My bad. My bad. So 7 is going to be placed right here for n. So 7 minus 1 is 6. Square root of 3 to the power of 6 means that I have basically 6 of these, right? So 1, 2, 3, 4, 5, 6. We know that this is 3, this is 3, this is 3. So the whole thing is 27. So 27 times 4, that would be, what is it? 108. 108. answer would be A sub 7 is 108. Questions? Okay, now that we know the sequence and we know the list, this is cool because he was talking about, so this prodigy, this Carl Friedrich Gauss. So Gauss, famous mathematician, as far as he was very influential when it came to like series and sequences, stuff that you're looking at now, that you can predict futures, and I'm not even kidding. Saw this documentary on this mathematician that even predicted and had proof and substantial proof and the math shown of predicting attacks. Like he predicted 9/11. I'm not even kidding. The date, the location, and stuff like that from mathematical models, and it's some crazy math that correlates with everything that we're looking at right now as far as series and sequences and stuff. It's very powerful stuff. But at 3 years old, this guy was finding errors in his father's payroll calculations. He was looking after his father's accounts on a regular basis by the age of 5. At age 7, he's reported to have amazed his teachers by summing the integers between 1 and 100. So 1 plus 2 plus 3 plus 4 plus 5, all of those at the age of 7. And instantly, where he could do it in his head. And he knew that it was the sum of actually 50 numbers that were paired up. So it was the last, first and last, the second and the second to last, the third and the third to last, so on and so forth. And by the age of 12, he was already getting, attending gymnasium and criticizing Euclid's geometry. Very awesome, and he's very huge contribution when it came to series and sequences for sure. All right, series. When you see patterns, guys, it's awesome. But when you are adding patterns, it's even bigger as far as what you can do with this information. So here we go. If I looked at this sequence, notice the difference. Sequence, what 4-letter word did we say at the beginning of class that was the same as a sequence? A list. It's just a list. A series, guys, all it says is just add the list. That's it. Add the list. So if looking at this list right here, can someone tell me what a sub 4 equals? Looking at that list, what's a sub 4? 9. What's a sub 2? 5. What do you think S sub 2 means? Series. So up to the second term, add them up. So what is S sub 2? 8. Because it's equal to that 3 plus 5 to get 8. What's S sub 5? We're going to list them all out. The first 5 terms. 3, 5, 7, 9, 11. But we're not going to separate them with commas. We're going to S. Summation. We're going to add them up. And there was no coincidence of why they choose A for amount at 4 is 9. The amount at 2 is 5. And this is the summation of 5. What do y'all get for that? What is it? 20, 22? 35? Yep. Are we good? Alright, so series and sequence. That's the difference. Now, notation. Not only can you do it with an S, you can do it with the summation notation. Okay? This I'll show you in the calculator. It's pretty easy, but understand what it's doing. This is saying starting at 1 and going all the way to 8, and I'm talking about n-wise, we're going to plug in a number, plug in a number, plug in a number, and add them all up together. So, let me show you visually what's going on. For the first 3, we would have, for this equation here, 18 minus 3n. Which number are we going to plug in first? We're going to plug in 1. Okay, so you will always start with 1. Okay, so guys, plug in 1 into this equation for n. What do you get? 15. Okay, now what comes after 1? 2. So the second integer, plug in 2 into the same equation. What's the number? 12. Plug in 3, and this is where we're going to stop, guys. This is the limit, the upper bound. This is the lower bound, and this is where we stop. So let's plug in 3. We get 9. And what are we going to do because it's a summation? We're going to add. What do you get? 36. Okay, this one says add them up all the way to 6. Okay, not to 3, but to 6. So we've already done the first 3. Now, when n is 4, 5, and 6, well, if it's 4, it's going to be 18 minus 12. That's what? 6? If it's 5, it's 18 minus 15, which is 3. And if it's 6, it's 18 minus 18, which is 0. And all we're doing is adding this so that we're going to get 45. Straightforward, right? And then 8. It'd be the summation from the first jump all the way to the 8th jump, putting it into the equation of this. And let me show you something that's cool. You could just put it in your calculator by pressing this button right here. Oh, no, not that button. This button right here. And we're going to pick the summation one. You can see it right here on the second row. Say again? So this one right here next to the book. We'll pull up that screen. Okay? And now we're going to go from what it said, from the first jump to the 8th jump. So let's put n or x, it doesn't matter. Just be consistent with your equation and the explicit formula. We're going to the 8th jump. And we're going to do 18 minus 3n. Now, 18 minus 3x. Will it work? No, because those variables have to be the same. So we can put x for both, or we can put n for both. And not only will it know the list, it will actually add it all up just like that. Check this out. Menu 2. Is there a sequence one here? Fraction, number tools, fraction, number tools. Sequence, sequence, sequence. I think it was some other one. Maybe it was algebra. Do y'all see something sequence-wise? No? Polynomial tools.
Series
Where do you see it?
and calculus C.
Calculus? Okay, so, oops. Menu 4. You see series, but sequence is not there? Okay, because I know that there's a sequence one. I just forget where it's at. Let's try spelling it out. So it should be italicized. I'm trying to give you shortcuts as far as using this. So C. Oh, then there it goes. There, it's not italicized anymore. Okay, so if I put the parentheses, I can put the equation is 18 minus 3x, let's say. And let's say that I wanted the first 5 terms. I think I have to put another x. Yeah, I think I have to put another x to make that work. And it will go right here, I believe. No, I have to look at that. But I know that there's a way that you can do it to where it will list them out as far as the numbers quickly for you. Maybe it's n. Oops. Okay, so one more thing. Oh, nice call. So we'll say 1, thank you guys, 1 to 5. How's that? Does that work? Are you already ahead of me? And then comma n. It's something like that, and I'll show you next time if it doesn't do it now. The last thing that I can troubleshoot thinking about would be, let's put n first. N's first? Okay. Thank you, Cooper. So n is your variable. You're going from 1 to 5. Bam. There it is. It'll show you the first number is 15, the second number is 12, so on and so forth. Thank you. Are we good? All right, so now you know how to do that. This one right here is showing, here we go. This is the last piece, guys. This is the last piece, and we're done. Can someone look at these equations right here and tell me what's the big difference that you notice that's going to confuse you if you don't know how to use a certain letter? What's the big difference? Not only that it's a fraction, but something other than that. Not the multiplication. All the other ones that we've been doing have been to the power of what? N minus 1. You with me? So whatever number was here was typically the first number here. But because it's not n minus 1, this one is actually going to be 4. Because you would put, here we go, watch, 1 right here, 1/2 to the raised to the power of 1 is 1/2. And when I multiply it with 8, I get 4 as my first term. So your first term isn't 8 per se. Your first term is going to be 4. If it was written like this, and I asked you guys, what is your first term? That means, what is n equals 1? What's 1/2 to the power of 0? 1. So the first term would be 8. Do you all see what I'm saying, guys? But here it's 4 because it's not n minus 1. It almost feels like it's the second term. Okay, we'll get more into that next time. And then the summation is just adding them up and seeing what you get as far as that series is concerned.